Good morning, everybody. I'm Shixin Zeng. So I know some of you already know me, but some of you guys might not. I have been with Atronix for over 7 years, and have been working on Rebol code ever since. I started at user native, and the extension interface and the make system, the Rebol make thing. And of course, today's topic, FFI. So first, why we need this feature. C library, it's everywhere, and we cannot just rewrite the whole world in Rebol. That's just impossible. So with this interface, we can just talk to pretty much everything. And this C library is probably the most common API among different programming languages. Like Python has like Fidelity and Rust and JavaScript, pretty much every language. But not every language can talk to a C++ library. And yeah, same thing for others. But C library is pretty common. And another reason for this is one advantage of Rebol language is that you can very fast write a script, just get it done, and you just throw it away. Same thing, if you want to use a function from some C libraries, you can just use this FFI to call that function and get your thing done, and you can forget about it. And actually in Rebol, there's another way to interface the C functions, which is writing an extension. But that requires a C development environment because you have to write C code, of course. And you need at least understand how the extension interact with the core so that you can exchange the data between them. With this, you don't need to worry about that. So my goal was actually to be able to call or interact with any C function from within Rebol without writing a single line of C code, which includes support of different APIs. API stands for the application binary interface. In here, it refers to the calling convention. So for C function, you need first to pass the parameters to the callee, and then you need to get the return value from the callee for your use. The way to pass the parameters to another function varies depending on the CPU and the operating system. It's not in the C standards, it's in the compiler. Probably not everybody notices that, but if you really look into the C header files, you might notice that because most of the Windows calls are standard call, which is different from the C function call convention. And it should be able to locate a function by the name or by the address because some of the libraries do not always export the symbols. They could just export a table of functions and another function for you to load the functions from that table. In which case, you will just get an address to a function point. I want to be able to write that kind of function as well. And of course, you need to be able to support all the data types that C could support, like all the primitives, like integers, floating points, and one of the big part is the struct. And another thing is the pointers, because pointers are everywhere in C. Another thing is support the callbacks. It's very common you pass a function to another function because in C there's no generic or function object as in C++. So for some of the generic algorithm, you have to pass in some callbacks to do certain things. But in here, we don't want to write C code, so we need to pass a C function point to a Rebol function. And we need to support the variadic arguments to C functions. In one of the example is printf, and this FFI be able to support that kind of function. So here are the building blocks for this interface. First, of course, the Rebol FFI, which is the very popular and mature library to support the runtime C function calls. There's some, I think, assembly language there to do this work. In this Rebol world, we need these 4 data types for this feature. First thing is the library, of course. You need to open an external library. The second one is the struct, which is very important in exchanging the data between Rebol and the C function. The third one is the routine, which is just a wrapper to a C function. The fourth one is the callback, which I just talked about, passing Rebol function to a C function. So first, the library, which is pretty similar to what we have in Rebol 2. So you just call this make library and pass a file. So this file path could be an absolute path to the library file on your system, or a file name, which in which case it will use the system search path for the library. So like here you can just do a libc.sr.6. It will search the system for this library. Or if you have your own library that you don't want to install into the system path, you can just put the absolute path to your file and it will load for you. Next thing is the struct. It's very powerful in this interface. First thing, of course, it needs to be able to wrap the C structs. And it can also be used to perform some of the data conversion, like to convert from decimal in Rebol to a single precision float in C, because in some cases you do need that conversion. You can use it to access the memory directly, because like I said, in some cases, the return value from a function could be a pointer to something, and you need to fetch the data behind that pointer. So you need to access that memory. And it can be used to reference the external data symbols. Some libraries will not only expose the functions, it could also expose some data. So this struct can be used to access those data points. So first, this is how we can wrap a C struct. Left is the C struct, and on the right is the wrap in Rebol. So it's pretty, I think, straightforward. In Rebol, we have the variable name, then the data type inside a bracket. And if you look at this here, it's not just a word, it's a set word. In this case, you can initialize this field after the struct is constructed. And another thing you need to be aware is that in C struct, the compiler will do all kinds of the alignment based on the data type of the field. So say if you look at this field, it's a pointer. On most of the CPUs, pointers have to be aligned on 32-bit, I think, to multiple of 4, and on 64-bit, it has to be aligned on the multiple of 8. If you look at this, the offset of that one in this struct is not multiple of 8 or 4. This is a 2-byte and that's 4, so it's a multiple of 2. So you need to pad that. So here, if it's 64-bit, then I pad with 3 2-byte integers. So this is the third field. Data type is just a single point, because In the struct, we don't really care the data type this pointer points to. We just need to know it's a pointer. The thing we care about at this point is the size of the data field. So the size of the pointers are the same no matter what they point to. And we can also wrap the array. You just need to put the size of the array after the data type. And it can also do the nested struct. This is something that Rebol 2 cannot do. So, like I said, another feature of this struct is doing the conversion between the Rebol value and the native representation of the primitive data type. So here's the Rebol code. So you just convert that to the IEEE 754 double precision representation of this number. So, but here I just want to show you the size of this representation to confirm it's a double precision. It's not single precision. The single precision should be the 4 bytes. And here is how you can use this struct. So if you specify the data type of the field as a float, that would be a single precision. And the size of this is float. And here you can do the same thing, but compare this one and this one. What's the difference? They're just this one just a reverse of that one because they are in different endian. In Rebol, it's in big endian, but because this is the native representation of the number, so on the x86 it's little endian. And this struct can also be used to access the memory directly. So it's very common to have this kind of code in C where you have struct and you store this thing into something, into a context or into an array or something, then you have a function to find this stuff by some ID or something. And that function will just return a pointer to your stuff. And you need to interpret this pointer. You need to access the field that is pointed by this pointer. So in this case, I just call it the raw memory. So you just need to put the address of that point as the value. Then everything else is the same as other structs. Then you can just access this all of the fields, but the Rebol path. So for ID /info, you will be able to access that. One thing you need to, of course, be aware of this address must be valid address, otherwise that would be undefined behavior in C term. So anything could happen. So here is an example to access symbols. I'm using another attribute called extern, which is the library and the name of the variable. I forgot his name, who was just asking for this feature, how to access data from these n courses. I can probably add this. Okay, now the routine. So this is the example of wrapping the printf function in C. Looks very similar to the C function spec. So first you can have the inline documentation of the function. Then you can have the argument name and then the data type. Then an optional comments for the argument. And then here you can actually have the variadic arguments. Just use 3 dots. And you need to specify the return type because return type is part of the C function prototype. Then you just specify the library where this function is and the function name. So this is how you call this function from Rebol. Because this is a variadic function, the number of arguments is not encoded in this function prototype. So you have to have a way to know when the argument ends. So I put all of them inside a block. Here we just use the dots, but we can provide 2 arguments to this function call. But because this FFI has to do the data conversion, so it has to specify the data type it converts to. And like I said, functions could be fetched by another function. The OpenGL functions is a perfect example. So first, it will call the get proc address to load all the OpenGL functions, and then they assign all the function pointers to some other named function pointers. So you can use those named function pointers to do your work instead of use the just arbitrary address. So to grab this kind of function, this part is the same as other routine. It's only this part. If you remember what I showed in the previous slide here, it was library, then the function name. Here you have only one entry, which is the address to the function. And the APIs mentioned before. So on Windows, it has there's so many different calling conventions. And on Unix, it has fewer, but still more than one. And on different CPUs, you have different calling conventions, ARMs, MIPS, and it's very simple to support different APIs. All you need to do is to say API column and this STD call or your systemv or Unix 64 or you can just use the default. There's a default calling convention for each platform. So example for the callbacks. Quicksort is one of the sorting algorithm that's very generic and fast. But for this function to be generic, it doesn't define how the elements in an array is compared. Which one is should be in front of the other one. This is something the caller of this function needs to do. So that is done by a callback. So we need to provide this function a Rebol function to compare two elements. So this is basically the callback function. Here I am trying to sort an integer array. So I assume that it'll be integers. Of course, for this C function, you can use it to sort anything. So if you look at the parameters to this function, there are two pointers. Here I'm using the raw memory attribute to retrieve the data behind that pointer, and then just compare them and return 0, -1, or 1 for equal, less than, or greater than. And this is just a wrap around this Rebol function to make it a callback so that C can call it. At the call side, the caller of the function could provide some extra information. And that extra information will be passed to the callback function. And because this callback function is written in Rebol, it's very inconvenient if all we have is the C data types. That means we just cannot pass any Rebol values from the call side to the callback function, which is a Rebol function. So I came up with this idea to wrap a Rebol value into a struct and pass that struct into the C function, which will in turn be passed to the callback function. And in the callback function, you just can recover this Rebol value because the callback function is a Rebol code, so it's very easy to work with the Rebol values. So all you need to do is just say this is a Rebol value, and you can pass whatever Rebol value you can pass to this struct, and it then will be recovered or retrieved in this callback Rebol function. So this is a function from GTK. Okay, now it's demo time. So hopefully it works. This is David's laptop. I'm never tested on this one. So 3 GTK demo. Oh yeah, it works. So this is basically a simple, straightforward port from the standard GTK demo from the GTK repository. This is a demo from a few years ago when I first worked on this, as also a testing of this binding. So this is a 100% in Rebol. So it's just using the binding to GTK. So here you can double click. It's that this should, yeah, I don't know what, just some random thing. Yeah, I didn't implement all the actions behind these buttons, but at least it doesn't crash. So that's make that happen. Actually, I have a tool to generate the bindings to C libraries, because the GTK library is a pretty huge library. It has different components. It has glib, it has Pango, it has ATK, it has Carol, it has a lot of things. So if you really want to manually wrap every function of that, that's going to take a while, and you will probably make mistakes there. So, and it's very mechanical. So I just wrote this tool. I call it C2R3, because it from C libraries to Reb3 functions. It's based on the command, because I don't want to write another C parser, and that's pretty takes some time and not good enough to parse every C header files up there or to support all the C extensions. So yeah, because this lib command is pretty good. It comes from command, of course. And another interesting thing is that to use that library, I need a wrapper around that library. And that wrapper is generated by this tool. So I first handwrite a simple wrapper around some of the essential function in this lib command. Then I finish this tool. Then I rerun that tool again to generate this lib command wrapper. That's pretty much it.
Super cool.